Hey everybody, this is Larry. This is me doing extra practice. Going to actually I'm gonna take off the premium because I think there are non-premium questions that I haven't done yet, so I'm going to just do that. The only thing that I will skip over for now is I think database and concurrency because I don't know. Like that's not I'm here for today. I'm just going to do algo. So as long as it's in algo, that should be fine. And today we do get a premium problem anyway with Amazon, I guess. I don't know. But it's 1634 add two polynomials represented as linked lists. Alright, I mean that sounds pretty straightforward so far. Let's take a look. And basically, yeah, I mean I think the way that I would think about these problems, or this particular problem. I guess this isn't really a classic problem, but the way that I think about it is kind of like a big num problem, or big number or big integer problem, and kind of think about it that way. But really, it's just about, especially for this one, if it's adding, it should be pretty straightforward in terms of the mathematics. It's just about yeah, because basically you have like multiplication, you have to do like some shift things, and then maybe you can get into complexity. Like there are a couple of different algorithms for multiplication, but addition is pretty straightforward. It's just about what I would call bookkeeping, and bookkeeping is not a fancy algo. I know that sometimes I say it and I don't explain it, but bookkeeping is just, you know, you keep a book, keeping track of where everything is and making sure that everything is updated when you update one thing and stuff like that, right? So that's basically the idea. All right, let's take a look at the actual problem. But I mean, I imagine the title is pretty. Oh, I didn't. I imagine the title is pretty descriptive. That's why I didn't really read the rest of it, though. You know, there may be some nuances or edge cases that they throw at you a bit. But yeah, okay. So you're given a linked list. This is the linked list node, and you're given the, I presume, the head. Is it sorted by power, I mean? Okay, so no coefficient 0, strictly descending by power. Okay. All right, that's pretty good. I think one thing that we can think about is whether, okay, well, I changed my mind a little bit, but I was going to say whether you do it in place or not. But given it's a linked list, it's kind of tricky to have it in place necessarily, just because, I don't know, then you mutate a lot of things. And I don't know. I just keep it stupid, keep it simple. That's what I would say, right? But I think the idea that I would have for this one, so basically, the way that I would think about it, or at least the way that I would describe it to y'all, is just kind of think about, instead of polynomials, think about it as big integers, if that helps it easier. And of course, for adding that, then you just get it one at a time, right? One digit at a time, and in this case, one polynomial at a time. Of course, you have to line them up. However, the difference between this and a linked list of digits is that there are no placeholders for zeros, right? So there may be missing things, but of course, you still just kind of point it at one at a time. And with that, and of course, in this case, there's no carry, so you can definitely go from, what's it? It's not the most significant digit, like most significant polynomial. I don't know if that's quite the way. I don't know the terminologies now that I think about it. But in any case, yeah, there's no carry, right? So you can just kind of add them piecemeal, one by one, or pairwise, if you will. Yeah, and that should be good. Of course, the only tricky thing is the coefficient of 0 stuff that we have to care about. So yeah, so let's just say we have answer is equal to a polynode. And here, I'm going to just use, what is x and y? Why do they call this x and y? Why do they not just call it like coefficient, you know? Like, why would you make code that is less readable than before? You know, I don't know. That's just weird, actually. But in any case, we'll use a sentinel. This is not a real head. It's just, you know, I think this is fine, right? And then and as a result, we'll return answer.next because that is the sentinel. Okay, and then now we'll just do something like while poly1.next is not none. This is another way of saying that it's not empty. Maybe we could put, well, I was going to say maybe we could have a helper function, but also ideally maybe that's like a function in polynode. So I don't know. But yeah, and poly2.next is not none. Then here we do some maps on both of them. And this is very similar to merge sort, actually, you know, the 2 pointers, I guess. I don't know. But yeah, if poly1 dot power is equal to poly2 dot power, then basically what we want to do is answer.next is equal to party node of the which was party 1 dot coefficient plus party 2 dot coefficient. The power is the same, so we just take one of them, and then next we don't have to care about yet, right? And then else, I guess else we have to take the power that is greater. So this is the one of them, and then else the other one is party. I like to type it out sometimes. Oops. If I type it out sometimes, I like to type it out correctly sometimes too. but yeah, right. So now here, the idea is still the same, and maybe we could have written this in a slightly different way. I don't know. Oh wait, we need to update. So yeah, hang on. This isn't done, even the previous stuff yet. This is just setting up the answer. Party 1 dot coefficient, party 1 dot power, and then here we want to do party 1 dot as you go to party 1 dot next. Maybe we could have a pointer to party 1 instead. Maybe that's. It should be okay though, just because this is actually by value, not by reference. So this actually is just a value, but okay, we'll just do P1 is equal to party 1, P2 is equal to party 2. Maybe that's slightly, I wouldn't say this is cleaner or even more readable per se. I'm just lazy about the reading, about the, I'm just lazy about the naming. You could probably name it slightly better. But it does offer less ambiguity with respect to pass by reference, pass to value, and all these things that people sometimes have concerns about. So yeah, you go P in that next, right? And here we right, we both, and lastly we have and right. Are we done? No, because then there are cases where one of them is still not done. So we have to kind of, yeah, we just have to finish it off, right? Is this true? No. Is this? I think I'm off by one here. There you go. But yeah. Yeah. Okay. But yeah, and then now answer.next is equal to party node P1 dot coefficient, P1 dot power. Oh, I did forget. I'm supposed to write answer is equal to answer.next. The reason why I didn't put it together is because I thought I could put it outside. But oh no, this is weird, isn't it? I am being silly. So this is head, but then we have, let's just call it tail is equal to head, and then now we return head.next, and this is the tail. Maybe that's a little bit clearer. Huh. Sometimes I forget these things. I haven't done it in a while. Like, as I always say, I don't really do much linked list stuff outside of LeetCode. It comes in handy once in a while, mostly like least recently used E kind of thing, but I don't know. But yeah, that's pretty much it. And like I said, this is going to look very similar to a big int type thing or even a merge sort type thing. But yeah, did I mess this up? Did I understand this? Oh, I renamed things and I deleted it. Whoops. I renamed something and then I kind of left it off. Okay. Oh, there is a case where the thing becomes 0. Okay. I mean, that only happens with this. So, yeah. So we can just do array symbol. That's a little bit tricky. I mean, it's not that tricky, but it just requires a little bit thought. So if this is not equal to 0, we do this. We still have to move this, but now we have to kind of move this along a little bit, so I cannot generalize it. This has to be here, this is here, we move, and this is here only if we update, right? Maybe we could have a helper function here, to be honest, but it's fine. And the reason why here we don't need a check is because we assume that this is already greater than 0. Or it is not 0, actually, not that it's greater than 0, because otherwise it wouldn't exist, presumably. But yeah, as I suspected, there were some edge cases, but luckily for us, caught on the input cases. But yeah, otherwise this is a pretty straightforward. Is this a medium? Yeah, it is a medium. Sounds right. It's a little bit tricky for for Yeezy, but a little. I mean, yeah. But yeah, how do I feel about this for interviews? I don't know. I wouldn't ask this. This feels a little bit straightforward, and I don't really like linked list problems as an interviewer. That's not to say that you won't get it, but that's just me as an interviewer. You definitely should know this. It's not that bad, and there are a lot of other linked list problems, if not this one. So, and if you're, if you're practiced on linked lists, this shouldn't be a problem for you. Yeah, that's all I have for this one. Let me know what you think. Did I submit it? I think so, right? Yeah. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.